Hi guys, this is Phys Universal and today we're going to look at the derivation of equations of uniform accelerated motion. Before we start, I'd like to remind you that you can comment, like and subscribe for more tutorials that are going to come up in mechanics, electricity and even in chemistry and mathematics in the derivation of different formula that you are using every day. So now we can just get into it and look at the way we can derive this formula, because they're very simple if you combine your knowledge of mathematics and physics. So now let's get into it. Basically we got three equations of motion as they're seen this way. We got the first one, the second and the third. So these equations just drive simply by just having the velocity time graph of here. This is the velocity time graph, velocity against time, and that's how I call it, velocity time graph. And you get different parameters that you probably going to need, as u, this is the initial velocity, v the final velocity, a this acceleration in times, yes, is represented by t, and s just the distance covered. So these are very important. So let's go to the point of interpreting the graph, the velocity time graph, because interpretation of graphs in physics is the knowledge that you need to have, and because going to find a lot of graphs in physics that require a very deep understanding of interpretation of graphs. So we have this velocity time graph, and here I'm going to interpret as follows. So basically we have the body with the initial velocity u and the final velocity v. It accelerated from its initial velocity to the final velocity v in a certain time t. It is shown there. So basically you can see that this body, it had a changing velocity, so basically it had the acceleration. So we can go ahead and find that acceleration, just simple like that. So let me open the other page. So here we have a very similar graph as we had it before. So here basically the body, we just say it was accelerating, and the distance from here to here is u, the distance from this point to that point is v. So basically the distance from this point to that point is v minus u, just v minus u. So we have the points. Here we got the points, 0 comma u, and here we have the point t comma v. This is very clear. Okay, so now using your knowledge of mathematics, we can compute the slope. And I've not told you this, the slope of the velocity time graph actually represents the acceleration. So we can use our knowledge of computing the slope that you have learned in coordinate geometry to find the acceleration. So the acceleration is basically represented as the acceleration. This is the rate of change of velocity. So to just change y over change in x. Okay, so changing y, you can just take these points t comma v and 0 comma u. So let's say v minus u over t minus 0. So we end up with v minus u over t. So this is gonna be our slope. So we can write a as v minus u over t, and we can just go ahead and make v the subject. So v is basically u plus at. So this the first equation of motion that you already know in the general course of mechanics. So now let's go ahead and find the next equation as I've illustrated here. So basically we have found the first equation, it is found. Now let's go ahead and find the second equation, and the second equation lets the distance covered by the body, and the distance covered by the body is actually given by the product of the initial velocity you multiply by the time plus half of the acceleration in the square all the time. So let's now see how this came about. So we got the same graph. So the distance covered by the body in the velocity time graph is given by the area under the velocity time graph. So the area under velocity time graph, we got two areas, the area of the rectangle and the area of the triangle. So the distance covered by this body will be given by, so yes, S, the area of the triangle plus the area of the triangle, the rectangle basically, rather. So this S will be the area of the rectangle is given by, so the distance from this point, yes, T, okay, distance from here to here, yes, U. So the area of the rectangle, yes, U times T. So as it is said, so this U multiplied by T. Then we add the area of the triangle, which is basically half the base just T multiplied by the height. So it is V minus U, then multiplied by T. Okay, just play it simple as from this point, this just the height, and this just the time, or the base, which is represented by the time. So yes, simple like that. And then we can just go ahead and do the rest of the things. So as, yes, ut plus half v minus u, then t, and from the first equation that is seen here, from the first equation, or from equation 1, which is v is equal to u plus at, v minus u is basically 80, and they say this is the third equation. Okay, then we can actually substitute the third equation to this equation around here. You can just take, because the value of v minus u is basically 80, so you can just put it there. So s is given by ut plus half v minus u, we just said from the third equation, is basically 80. And then don't forget the t that we had before here, t. Okay, so now it's not that difficult to understand, it's pretty simple. Okay, let's go to the next page, see how can we compute this. We still have the same graph we had. So basically we had s is ut plus half v minus u, then t, and we've said ut plus half at, then t will just beside. So we can just put this t inside, of which we're going to end up with ut plus half at square. So s is equal to ut plus half at square. This is the second equation that we had in the first page, and that's how it is derived. So basically finding the area of the rectangle, the area of the triangle, then you finish all the stuff that you need. Now let's go and find well, the last equation of which you are interested in. So the last equation depends on the first equation and the second equation. So basically the first equation is just v is equal to u plus at, and the second equation is ut plus half at squared. So the third equation will depend on the two found equation, the first one and the second one. So from this first equation, which is v is equal to u plus at, this is the first equation, and as I've told you that the third equation depends on the first equation and the second equation. So find the third equation, we square the first equation, square both sides. So using your knowledge of quadratic identity like this, you can actually do this stuff pretty easy. As I've told you, you combine your mathematics and physics knowledge, that if you needed to do a lot of stuff for physics. So basically this is v square is equal to u square plus 2 twice this times this, so u80, then plus a square t square. Oh, this can be written as 80 square, just simple like that. So using all the mathematics, you can just do that stuff, not that complicated. And then we just going to take out v u square this side, so u v square is equal to u no, let's leave it because it's simple like that. So then plus, let's factor out 2a. When you factor out 2a, then I'm going to remain with the ut plus well 80 square. That's what we're going to remain with. Actually just half, it's half 80 square, because 80 square divided by 2a is basically 80 square over 2, simple like that. And then looking at these stuffs in this bracket, you actually go back and realize that this is the formula find the second equation, ut plus half at square. This is the second equation. So putting this stuff, you can just do this. You know that this second equation was u is equal to ut plus half at square, and ut plus half at square is basically s. So instead of writing this stuff inside, you can just write it as s. So v square is equal to u square plus 2as. So this is the third equation. So guys, this is the end of the derivation of 3 equations of motion that we learned in your mechanicals, and this is how you can drive it. And in the next session, I'm going to show how can you do these stuffs using the word problem that we're going to have in the next session, and make sure that we'll find the equations. It's some equation that are going to use to solve a different problem, so you can use these 3 equations to do a couple of problems in physics. So guys, if you want to get in contact with me, here is my number. You can just call me, email me anytime. You can get my email from the description of this video in the ready stage. So be easy to communicate with me for more tutorial or for more advice. If you need some video to be made in mechanics time, so you can consult me, you can guide. So that's how you can explore the world, and that's the purpose of studying science. So now I wish you all the best, and I say bye.